Hey guys, how you doing? All right, today I thought we'd take a minute and we would talk about adding fractions with uncommon denominators. But instead of using the traditional algorithm, I wanted to take a minute and I wanted to use more of a conceptual model. I really wanted to draw it out to show you. And this is a great way to introduce it to children who might have a little bit of a harder time finding a common denominator. It just starts giving them that conceptual model, that visualization for it, and all they've really got to do is be able to count and draw some lines. So let's try it with this first one I've got here. And today I think we're going to start by adding together, let's say, 1/3 plus 2/4. So I got 1/3 plus 2/4. Here's what I'm going to do. I'm going to draw two boxes. And I'm going to try to make them as around the same size. But if they're not perfect, it's not a big deal. They don't have to be perfect. We're not looking for perfection here with our drawing of our boxes. I'm going to take my first box and I'm going to divide it into thirds with vertical lines. And then I'm going to shade in one out of those three pieces, showing 1/3. Then I'm going to take my second box over here and I'm going to divide it into fourths using horizontal lines. And I'm going to shade in two of those to show 2/4. Now from here, what I'm going to do is I'm going to explain it to them that I'm going to overlay these lines onto this model and these lines onto this model, ideally creating two identical graphical representations aside from the coloring in portion. So over here, I split it into thirds vertically. Now I'm going to split it into fourths horizontally. And so to do that, just divide it into fourths horizontally. And then over here, I'm going to divide it into thirds vertically. Now, from there, it's as easy as counting. First, I'm going to ask, okay, how many equal pieces did I break each square into? And you could go several methods here. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Knowing we have 12, you could multiply 3 across by 4 down, again getting 12. I'm going to tell them to start. Our new denominator is going to be 12. Next, I'm going to ask them, okay, now that we know we've broken them into twelfths, how many pieces do we have shaded in altogether? How many pieces of these twelfths do we have? And I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 12. And to get the basic idea and get them used to the system, we are again just showing them how we broke it into twelfths. We're going to shade them in, we're going to do some counting, and we know that's 10 twelfths. If you want to take it a step further, well, now you're going to talk about simplification. Obviously, when I look at 10 twelfths, or maybe not so obviously, I'm going to look at 10 twelfths and I'm going to think, can I simplify it? Well, if I am familiar with my times tables, in particular my 2 times tables, I know to simplify, I can divide my numerator and my denominator by 2, divide by 2, divide by 2, and I'm going to end up with 5/6. Now, there's just one way to do it. Again, it's a conceptual model, it's a drawing, but it's a great foothold into it, especially if children are uncomfortable with finding least common multiples, doing multiplication, trying to find those equivalent fractions. And ideally, that's where you want to get them, is to be able to do just the algorithm. But for the time being, if you can get them comfortable with this, and they can start finding this answer, then you could use that as your doorway to teaching them the algorithm. Well, anyway, hope you liked it. Have a good one. See you soon.